Hello everyone, ladies and gentlemen. I would like to welcome you here at Positive Hack Days, and today's presentation is Big Data in Security. Obviously, in practice, we are going to take a look at the typical configuration errors that very often are found at pin tests at Hadoop environment, especially when we perform Hadoop ecosystem audit for big data analysis. In the introduction, I would like to say a few words about the essence of my presentation. First of all, I would like to discuss Hadoop and big data, what it's all about, and take a look at Hadoop at the integral part of the analysis of the big data. And the second part of the presentation will speak about the typical Hadoop cluster configuration errors, Ambari, Hue, Zookeeper, Hive, etc. In the end, I'll come up with conclusions, summary recommendations, which will help you hopefully make your Hadoop cluster more secure. Who am I? I'm Vadim Shelest, working as a pen tester in this company, and I specialize in cloud security, Kubernetes, and co-creator of K8's Telegram channel. Hadoop, what it's all about. So I think obviously we just need to start with big data and what we mean by it. So it's big volume of the non-structured data that we use for an upcoming analysis. Regardless of the goal, whether it's building a model, whether it's the fraud transaction analysis, it's all a part of the Hadoop ecosystem, being one of the main elements, Hadoop. What is Hadoop? Hadoop, as I said, is an ecosystem having more than 40 components, all intended for specific purposes. Here we have a huge number of them. It's a very busy slide showing a great heterogeneity of this ecosystem. As for the methodology, the testing of the Hadoop clusters, it's a high-level approach to methodology, but according to that, we assume that we split this whole data by levels, by functions, and we single out 5 levels. Cluster management is not the main one, it's actually managing the cluster, adjusting the configuration, and performing some administrative functions. We'll just take a look at Ambari, Hue, data ingestions, etc. So this is how our data goes to the cluster. How do we put it in there, for which we will speak and check it out. Then storage, Hadoop Distributed File System, Apache HBase and Hive data storage layers, as we can obviously define them. Data processing, these are the tools responsible for data processing, actually data analysis, and level 5 is data access. That's where we can see some of the tools. There's a big number of them, and what we're going to cover during the course of the presentation today. What's this Hadoop cluster all about? If you take a look at this approximate slide, we can see the sources of data. Imagine these are the clouds, regardless of the provider. Amazon, Yandex Cloud, it doesn't really matter. We just put them into the cluster with the use of Kafka. We can use Flume, for instance, and Spark is actually used here as the processing layer. Then it goes to the Hadoop HDFS, and we can analyze them with the Hadoop Yarn. Then we have the data access layer. That's how we can interact with the data in cluster. And Ambari, Hue, and Zookeeper, there's a management layer tools responsible for the cluster configuration, its performance, and let's start with the typical configuration components errors of the Hadoop cluster. We can obviously see these bugs and misconfigurations that are very easy to utilize, but sometimes they can lead to very, very aggravated and sad consequences for the businesses. And we'll start with cluster management, Apache Ambari, which is a tool which is for the monitoring and centralized launch, shutdown, and configuration of all of the Hadoop services in the cluster. It's a dashboard, in other words, for the entire cluster. You can see the main metrics here on the screen. Here on the main page, and Apache Ambari, the default configuration of the Hadoop cluster of the Cloudera and Hotel Works. Ambari runs by default at 8080 port, which is the dashboard you could see at a screenshot, and the wizard. The launch wizard just provides you with the hints that the default data must be changed, because by default it's admin, just like everywhere. If we change it from the web interface, the installation wizard prompts you to do that, but unfortunately they do not prompt that it use a PostgreSQL database. And if we can connect to port 5432, all of the Hadoop projects, basically inner ones, would always get access to the host, so we can connect to the database with the default base SQL, with the Ambari, and then we will see two charts, user identification and user. What we're interested in is user authentication, of course. Here we can see the authentication key. If we just take a look at GitHub with the Ambari default admin password, you can find it and update user authentication, set authentication key, and change it to admin and get access to the interface. So as far as you can see, the exploit here runs very, very simply. It's just primary school level, but it may lead to very sad consequences for organizations, because it gives admin privileges to everyone who manages the cluster. You can encrypt it, you can delete whatever you like to delete, etc. So it poses lots of threats. We follow with Hue, Hadoop user experience, which is a web interface to administer Hadoop ecosystem elements, just like Ambari, with just one assumption. In this interface, we can use connection to different sources to analyze data. So we can interact with Hadoop HDFS, HBase, S3, compatible storages like Azure, Google Cloud, etc. In this monstrous tool with a very complicated interface, which is not an intuitive UI, they tried to include everything in there into this user interface, including data access and the analysis tool. You can run jobs on cluster workers and interact and process our big data. Thus, you can also have an ability to connect to the relational database like Hive, and everything works and works quite well, as far as you can see here on the slide. We move on, and Hue launches the port Q848, and the first user that logs in sets the username and password for administrator and sets the super user with the maximum privileges. This screenshot shows you how it's all organized. I was reacting like Jackie Chan in this pic. I was very much surprised to this authentication approach, because when we set default data of user and administrator in such a fashion, which provides us full administrative control over the entire Hadoop cluster, we get access to any configuration of any element, and we get access to data as well. And just one big icing on the cake, we get remote node execution with the editors. This is the Hue functionality that helps you get RC at all of the cluster nodes. By default, this authentication username password is used here by default, but Hue is capable in terms of authentication. It uses LDAP, SAML, etc. It's not included by default, but they all include it and can be configured. And this is how the password and the username are set here in the system. Let's just take a look what we can do with the user interface. We get the entire admin control. We can adjust this cluster, remove the components, change the configuration, edit accounts, and we change access by changing login and password, and we can look through all of the clusters. Thus we can see all of the logs from everywhere, and we can use them with we can use them further. We get the entire control over the creation of jobs at all of the nodes of the cluster. You can see this in the interface. You can remove a job which was launched, like, for example, 700 days ago, and all of the analysis will unfortunately be lost. What else can we do with Hue? We get access to HDFS data, Hadoop Distributed File System. Read, write, delete, encrypt, so violate the operations of the company. We can get access to the connected sources that are used for read and write. We can also delete that data, and we get an excellent opportunity to get access to the DBMS and S3 directly from the web interface, and we can upload everything from the cluster using the same web interface, and we can dump all these petabytes of data. The most interesting thing, RCE and running code on Hadoop clusters with the so-called editors. Here at these screenshots you can see them, and there's a great number of them, starting from Barshell and ending with Spark or PySpark, Scala or R. Those who can use them can try them. I chose this, the compiled version where we put the path and the allocation of our local file. We can send there the number of nodes where we can run this code, and we press play, and we get over and take over Hadoop. As for Hue, according to the Shodan statistics, there are 579 hosts in China and the United States mainly that are searched very simply by query title Hue, welcome to Hue, and they are launched in cloud providers, Alibaba, Amazon, Oracle, etc. deploy Hue as part of the Hadoop component in the default configuration. So if we do not remove the tick from there, from the checkbox, this Q4 port interface will be available, and practice reveals that admins do not read any manual on deploying Hadoop. In Amazon, it's actually printed there on page 18. You just need to read there. And Shodan does not reflect the entire picture, but basically reflects quite a lot. So this very, very simple scenario helps us take over this big solution and take over the company's activities. So very often we can see lazy administrators that managed to let this misconfig stay in the system, and there are sometimes when you have to spend quite a lot of time which company owns what and what belongs to what company. And we tried to contact some of the providers, just making attempts to make this world a safer place. We are done with Hadoop, and would like to say a few words about Zookeeper, management layer for cluster configuration. Here it's the console solution. You can connect it with the Zookeeper SLI. Here's the link by which you can download it, and port 21NT1, that's where Zookeeper sits and listens to this port that it listens to. You change the configuration on the node, and it changes on all of the nodes of the cluster with the ls get, create, and delete, very simple commands. We can delete configuration, we can create, delete, whatever. We can achieve the same effect as with Hue and Ambari, but with this console Zookeeper solution. By default, they do not imply any authentication whatsoever. You can configure it, but practice reveals that very often it's on and it's running and it's included and anyone can use it. Unfortunately, we checked this, and now we're going to talk about data access. Three popular tools: HBase, which listens to 170.10 port for the entire Hadoop. It's available without any authentication. It allows you to read config, settings, charts, logs, and process metrics. It allows us to see what kind of cluster there is, and we can use it for upcoming attacks, followed by Hive, which listens to 102. That's the port. It reads the configuration of the service, logs, metrics, and that's where you can get a lot of interesting information. Presto, that's a funny thing. Let me read it. So here we have this chart, login, and we have this username, and where we have this password. We get this inscription: password not allowed over HTTP. And I was looking like this panda, like saying, what the hell is going on? And it runs very smoothly by default. And more interesting information follows. Just take a look. Now we're going to take a look at data processing layer, Hadoop, HDFS, and Yarn. These are the main components by Hadoop. Everything is centered around HDFS. It has master-slave architecture. We have name nodes and data nodes. These are the ones that are responsible for information storage. As far as this architecture, we don't need to know it. We have master-slave architecture and two options, and Yarn is the same. Yarn is the engine which processes data processing. So That's master-slave architecture. We have a resource manager split into scheduler and app manager, and we have node manager. We have two components there. App master that launches container. That's how this service works, more or less. Now, let's see how we can exploit its misconfigs with Hadoop IPC RPC, the protocol by which we interact name nodes of Hadoop at 8020 port. And to get access to HDFS by the use of this protocol, we just need to craft 4 XML files. If this authentication does not imply, we can interact with the file system directly. I will be showing it to you more in detail, and we can launch these applications on nodes by Yarn, by using Yarn. Yarn is just a skeleton of any Yarn app. By very simple manipulations, it turns into RC. And you can find more information on it from this GitHub link, which I showed you at the previous slide. A few words about Hadoop IPC RPC. Core side XML is needed here, and its value. HDFS namespace. Take a look at Hadoop UI at 570 port that you listen, and you find all the values needed. HDFS site XML. So if you're interested about namespace, name node ID, all of the name nodes, there can be a great number of them. You can enlist them. We can get it in this magic interface. File number 3, mapped site. Everything which deals with the jobs in the cluster. You can find it on ports 18988, etc. And one lost file is the Yarn site. That's where you can find name node DNS or simply name node. We put this in the value fields, and we are ready to interact with Hadoop HDFS. So in order not to locally run Hadoop, please use this Docker file, the image. I just change the version if necessary. When we test this cluster, we assemble Docker image, launch the container, copy the XML file into configs, and these configs can be copied, and we copy property and make a few adjustments to VI, etc. hosts so that it runs smoothly. So we feed it to Hadoop. We feed our config files to Hadoop. With the Hadoop config, we list this directory. We try to create the folder named hacked. Trivial message appears on the screen. Permission denied. But it's all simple to change that. So it seems like we can export it.
And voila, we have the opportunity to work with the file system and, change the data and do whatever criminal things we want to do. In Apache Spark, which is an alternative for Yarn, a very popular tool that that is often installed together with Hadoop, and it is responsible for data processing within the cluster. And traditionally, Spark security, things you need to know. Security in Spark, so this is quite obvious and does not require any comments. By default, this is This is it. And let's see how we can work with Spark. So Spark has a remote procedure call protocol. We have a web interface, same as for all Hadoop tools, 8080, accessible without authentication, and allows you to get the preliminary data on what cluster is in front of you. And we see here some info regarding the workers, active workers, inactive workers, resources, memory, stuff like that. And with Spark RPC, the calls are listened at 7070 at the Spark master node. And we can actually detect it with Nmap, is the go-to tool for all the pen testers. But unfortunately, the way Nmap tries to identify the Spark is not sufficient because the fingerprints are not written well, so it's better to run a script like this that allows you to identify Apache Spark on 7070 and the authentication not required is a very useful piece of information. So Apache Spark works in two different modes. We have a client mode, so let's learn what it is to understand. And we have Apache Spark master interface at 8080. We have RPC at 7070. And if the cluster works in a client mode, then the driver, which is responsible for slicing and chunking the tasks and sending them to the cluster manager using the RPC protocol, and then the cluster manager would send the data to the workers. So the driver is placed on the local workstation and is used to connect to the cluster manager. In this case, we can, of course, get an RCE or the functionality that is provided by Apache Spark. So using this snippet of code by sending the IP address of Spark RPC and sending the address of the machine where we have the driver running, our attacking workstation. So by parallelizing the commands using this snippet, we can run the needed ID on all the nodes of the cluster. This is a client mode. And there's another option of Spark running in a cluster mode. And obviously the driver is not on our laptop then, but we rather work with the cluster manager using the RPC protocol on 7077 port, and we say, hey, here's the code we need to execute, and you need to decide where to run the driver. Accordingly, as well the same, we cannot do anything on PySpark because those are the peculiarities. And regarding the cluster mode, when the driver registers the application, working together with the cluster manager, it assigns the workers. And the cluster manager sends this information to the workers. So it would be a logical idea to say that the driver only initiates the registration that needs to be processed. And then the workers connect using the RPC protocol with us. And if this connection is lost, then this trick will not work. But quite often, we still see this running and successfully executing. And if the driver works in a cluster mode, we can then run the Scala code, the jar payload that is run on the given amount of worker nodes in a cluster mode, and when the cluster is configured. So this structure is some template that allows us to run some code. We need to, of course, install Java, create a jar file, and then feed it to Spark. Spark REST API has an option to walk through REST APIs, same as RPC, and we can set tasks to Spark using REST API. And there's nothing to explain here. We already have a Metasploit module that allows us to get RC, and you all can use Metasploit, right? The idea is that the authentication is not needed, and we can send a JSON to get an RC. There's an automation tool, Sparky, to avoid doing everything by hand, not crafting the files. You can use this link to download this utility from GitHub, get the dependencies, and that's it. So generally speaking, this is a tool that allows you to do everything I told you about, but in a more automated mode. And talking about Spark Client Mode RC, we can use just one command to get RC through Sparky, and if we send Spark Master API to our driver machine, then the command should be ID and then 3. This is the amount of nodes of the cluster. And with that, we get the RC on the given nodes of a cluster. We can even do it for all the nodes. And there's another funny script. We can do the same, but automate the information gathering. So using the script that is called Cloud Scripts, we can get access to the internal infrastructure of the client using the credentials that we can change in AWS and the DigitalOcean. And the only thing we need here is just the access key and the token, if we talk about Amazon. And on the screenshot below you see how it works. And also the search secrets script that allows you to find the secrets for the workers of Spark cluster, and using regular expressions it get that beautiful output of this utility. So with that, we are close to conclusion. And in these 40 minutes of my discussion, of course, it is very hard to overview this huge topic of Hadoop cluster security, and accordingly, I think we've looked at some things, and let me give you some advice. So first of all, we need to have layered security of Hadoop cluster on all the abstraction layers. Management layer, data storage, you need to be mitigation-wise. You need to look through all the functionality of the tools. We also need to isolate and segment the key infrastructure of the Hadoop cluster according to zero trust and least privilege principles. As you saw, everything is turned off, firewalls are turned off, and some instruments, some tools are just writing in bold red letters that to use it properly you need to turn the security off. So if we want security, then we need to turn security on. So everything that is off by default needs to be properly configured. All those mechanisms are present there, but they are not always easy to configure. You will need to spend some time, but of course this will pay back in the future when you see the intruders coming. We also need to configure the authentication mechanisms and to ensure authorization is done properly. We would like everything to work using normal protocols, and to be able to use whatever we need. So anything will be safer than, this Hue style password setup. And it's applicable to all the pen tests. So, password policy is a go-to, different registries, non-dictionary passwords, MFA, hardware tokens are the best choice, and of course strong application security and regular pen testing will be your path to success. Thank you indeed. Thank you indeed for being with us and for your attention. Thanks. I think there's a question there, right?
Простите, извините, но теперь можно задавать вопросы.
Yeah, you can now ask your questions.
Добрый день, спасибо за доклад. А можете вернуться на слайд про уязвимость Spark?
Hi, thanks for the presentation. Can you switch back to the Sparky slide where you could upload the jar? Or just simpler. Should you just add an authentication there? Yes. There you have some options depending on your authentication schema. Things you need to implement will change, but the idea that you can, send a jar there, Spark does the same. And so to mitigate, you need to base the mitigation on your case. If you have such a risk, then you need to implement that layered defense. And how you do it depends on the infrastructure, and of course you need authentication. And the first case about Hue. Can you explain again? When you connect to this interface first, it gives you an option to define a superuser, right? Yes. And if you have a superuser in the database, you can create new users, right? Yes, absolutely. So Hue itself has its own roles. An admin, a superuser. So when it starts, by default, in the cloud, in Amazon, you just, put a checkbox in front of Hue. So the first person finding and logging into Hue just gets a superuser. And there's no admin there. We will create an admin, and thus we have an admin, we have a user with admin rights. So we can create a lot of users. Thanks much. My pleasure. Hello. Maybe the question is stupid, but in terms of blue teaming, all you showed was misconfig, and the question is, what's about the compliance of the given tools? Are there any ready-made modules for popular scanners to find obvious issues, administering issues? And the second question is, what do those tools have in terms of logging? Because it's especially interesting for changing jobs, because it changes the logic completely. Yeah, I get your question. Thanks much. Great question. And I will start from the last part regarding the jobs. In one of our projects, cannot name the company or any details, but I will give you an overview. Randomly, by pressing the wrong button, I was able to kill the job that, well, not 700, but at least 70 hours. That worked for 70 hours. Just looking through the interface. Funny part, right? And regarding the blue team approach and logging, yes, logging can and should be set up, and by default each tool provides you with logs, and Embary can help you gather it from all the nodes and look at all the data. Cluster-wise, I don't know whether we have some ready paper that will give us all the misconfigs, but pentest is probably something that can be recommended and as an optimal solution. We will look at everything, and finding those misconfigs, we will report it to you. Well, but it's expensive, and I think every change, every deploy can, should be followed up by a pen test. Yeah, I agree. And the alternative here is a lot of work with the settings and reading the documents. And each of them has very much detailed description and manuals. I think, from my experience, no one reads the manuals. Yeah, Dr. House said everyone lies, and I can add that everyone is mistaken also. Correct. Everyone makes mistakes. Thank you. Thank you for the presentation. And I would like to ask how long all this will keep happening. But, okay. Hardware keys are great. MFA are great. But as a user of that hardware thing, the question is, it's always in my PC, and I never take it out. And if I was hacked, then here are my keys, visible to all the world. So the question is, how can we solve this? I work with Hadoop as a full-scale ML engineer, and it's not very probable that I will, switch the keys always or remove it. So how do you protect it hardware-wise? Thanks much. Great question. And cybersecurity related. Theory says that you need to balance the convenience and security, because you have a lot of displeasure from the obvious ordinary users, but you need to find the balance and maneuver around the issues. Using hardware tokens and MFAs is an obvious advice. We saw Hadoop clusters in serious companies with a lot of requirements for cybersecurity and high maturity. So, layered defense, mitigations everywhere. This is how it's done. Hardware tokens, jump host, authentication, all works well. But in the case that I was describing, there was Embary, there was passwords SQL file, and we just used credential stuffing, a very serious password. So you need to find your golden, ideal balance between convenience and security, and this is a fight here. Thank you. You've mentioned the fact that the best practice is isolating a big data cluster, for example. And in my practice, I keep seeing that this is part of some internal virtual network. And pretty much all cloud providers create their virtual network, and everyone suggests jump servers, but there's usually a checkbox to remove it. And I often see admins, just putting a distribution software and a direct access, and no one thinks that this was not thought about in terms of security. Even adding Kerberos there is very hard to do. And I see that they sometimes put it in the ordinary segment. And yeah, great question. Regarding the pen test projects for Hadoop, usually we are hired by companies that invest in checking the quality of their security, so the default settings are not used. But the misconfigs that you can often find, based on Shodan, with companies that don't have enough maturity or enough personnel that works with security. So those misconfig cases are more popular within the companies that are just starting to think about cybersecurity, or after the incident, when something has happened with the data. If I may ask the next question. Isn't it a good advice for the companies not to create self-hosted clusters? At least the cloud players will have some understanding of security. And, well, I agree. And this would be a great solution, if not for example, AWS case. We saw that huge issue. We worked with Amazon representatives. The responsibility model is fully put on the client of the cloud. Everything that is above hypervisor is responsibility of the cloud provider. So everything that is higher depends on the client. And they put the blame on you. Does AWS work with WPC? The two options are available. I think we are... No, we are not done with the questions. Okay, another question. Hi, thanks for the presentation. And my question is not to the hardware, but more to the organization. Because working with big data means you need a lot of data from everywhere. And security people from many companies, they surround it with, 3 layers of security, and you need to, go through an RDP to a specific server where everything is closed and you're identified, and you can move that data only by moving the file. And so even to run a very primitive analytics, you need to spend 3 days to just gather the data and understand that you don't have something. So you spend a lot of time passing through the security. Any recommendations on how we can fight with that, like limiting the amount of activities of the security people? Just saying enough. Great question. I think it's an often happening story, and we see this a lot. But I am a security guy, and I will not be giving you such an advice. This is not something that I know about how it can be stopped. But if you find a balance between the security and usability, if this is not usable, then you don't need security if you cannot get access to that data. With people working with Jupyter notebooks, they often complain that you have put so much security on top of this that this cannot be used. But at least this is safe and secure. At least that data is safe, we can work with it, and there might be petabytes of data. Maybe the company has worked with it for years, so that would not be very convenient if this gets hacked. In your research, you would advise on that? Because the question was asked many times that, someone should have been motivated and say that, at that point you've over-secured the system. And this is, I think, an abstract discussion, but the more I look, the more I find that the question that the more security there is, the less usage there is, and people leaving to foreign resources that are more required, more convenient, and we wanted to create a safe and secure resource, but it's not usable, and we start using some, back doors, and those back doors are used to hack us. I agree. But unfortunately, there's a lot of philosophy, and we can keep talking about this, but there's no silver bullet, there's no solution. In my opinion, this is just, find the balance and not overdo this security. Get your feedback from the admins of the service and analysts. How comfortable are they working with that? And I think this is the reply I can give you. Thank you. Any other questions? I don't see any raised hands. Okay, thanks. Time to choose the best question and give the gifts. Thank you indeed for the questions. They were really interesting. It's hard to choose the right one, but this guy, I think, was my favorite, and your question also. Thanks.